Hello everyone, this is Shripad from SDMCET Dharwad. Team Alpha is conducting some different technical sessions. So today I am dealing with pointers. I will open my PPT. So coming to pointers, what is the technical definition of a pointer? A variable that stores the memory address of another variable. To visualize this thing, let's take an example of a memory block. This is the memory block containing different blocks, that is 3000, 3001, 3002. Here, a variable is declared with the name num and it is storing the value as 70. So the block will be having some address. Here it is 3000. Usually it varies from machine to machine. Some machines will be displaying it in the form of hexadecimal, some maybe in the form of integers. So 3000, 3001, 3002, 3003. So this is a pointer variable which will be storing the address of this variable num. That's why here it is storing the data as 3000. In turn, it will be having some other address. Here it is 3003. Next, why we use pointers? There are many applications of pointers in C language. One of them is dynamic memory allocation. In C language, we use different types of keywords like malloc, calloc, realloc, so that memory will not be wasted. And even we use pointers as a block of in functions, arrays, structures. It reduces the code and improves the performance. Next, declaring a pointer. So it is declared using asterisk symbol. Here, asterisk symbol is called as value at address operator, and ampersand is called address of operator. Uh, Here, let's take an example. Here, an integer data type of num is declared, which is storing 70. Int star ptr is pointing to the address of that number. To verify it, here I am declaring another uh, variable called as underscore num, which will be storing the value at address of that pointer. To display these things, we use percentile p as a format specifier. Even sometimes we also use percentile u, that is unsigned integer. Okay, just to verify it. Just to verify it, I am using Visual Studio Code Editor. Let's open that folder. I will take a file, example.c. So include the header file, include stdio.h, integer data type num, which is storing the value 70. Next, int pointer star ptr ampersand num, int underscore num is equal to star ptr. So let's just display them. Printf percentile d \n to display the content of underscore num. Let's display the address. And we'll use percentile u. Let's just use percentile p. Percentile p \n ampersand num. printf percentile p ptr and 0. Let's just save this. So here we can see the output. Underscore num is storing the value of 70, and these are the addresses which are saved. So just for readability, I'll make them into unsigned integer percentile u. I will save this code and run it. Here we can see the address. Let's move to the next thing. For a practice, I am taking one example block of code. Pointer is declared, a variable x is declared of integer data type. Pointer is pointing to the address of x. So here I have created two blocks, x and pointer. If suppose x is having an address as 3000, pointer will be having a data value of 3000 as it is pointing to x. This statement is very important. Star pointer is assigned with 0. So here pointer pointing to 3000 address will be, that is the value of x will be 0. Next, these are the display statements printf x and printf star ptr. So here it will display 0 in both the cases. Next, pointer is incremented by 5, that is star ptr equal to star ptr plus 5. So here it will be 5. Again, in both of these statements, x is equal to 5, star ptr is equal to 5. Again, pointer is incremented. So finally, x will be 6. Let's verify it. I will copy this block of code. Save the thing. And I will run it. So here it's verified. Initially x is 0. Even star ptr is 0. Pointer incremented, x is equal to 5 and star ptr equal to 5, and finally x is equal to 6 as it is incremented once again. Moving on to the next thing, there is a concept called pointer to pointer. So what is it? A variable that stores the memory address of another pointer. So pointer is storing the memory address of a variable. In turn, pointer to pointer, it is a variable that stores the memory address of another pointer. We use double asterisk as a declaration int star pptr. For storing the character data type, we use char star pptr. Next, coming to the concept called null pointer. So what is a null pointer? A null pointer is a pointer that doesn't point to any memory location. Simply, it is a wide location. Here, it is used to initialize a pointer variable when the pointer does not point to any valid memory address. Moving to the concept called dangling pointer. A pointer pointing to a memory location that has been deleted. In dynamic memory allocation, we use malloc, calloc, and once we are used with those blocks of memory, we free the thing. So it is called a dangling pointer. The dangling pointer can point to the memory which contains either the program code or the code of operating system. So uh, here I will take an example of dangling pointer. Int main so int star ptr is equal to int star, here I am using malloc, size of integer. So int, I declare a variable a, it is having some value. Let's suppose it is 400. Pointer is at ampersand a, pointing to a. Then free ptr. So I'm freeing it. So this is just an example of how dangling pointer works. Next thing is um, to practice a problem on pointer. I am here taking a C program to input and print array elements using pointer. Let's code it. I will make a file print array.c. Include the header file. As we are dealing with the arrays, to maximize the size of an array, I am defining it hash define max size as 100 into main. So int array of max size, then I am declaring a variable for storing the size of the array. Let's suppose it as a n, and one iterative variable I, and finally int star ptr to arr. Here pointer is pointing to 0th location of an array. We will ask the user printf for size of an array. Enter the size of an array. Scanf percentile d ampersand n. Next, we'll ask for the array elements. Enter the array elements. So for reading them, again for loop for I is equal to 0 to I less than that size, I plus plus. Sorry. So I will scan the elements percentile d ptr. Next, to move the move pointer to the next array element, here I am incrementing it pointer plus plus. So we are done with this block of for loop. Next is just to make sure that pointer again points back to first array element. Again pointer is assigned to arr. For displaying the array elements, printf array elements for loop for I is equal to 0, I is less than n, I plus plus. Printf percentile d rptr To print the value pointed by a pointer. So increment the pointer. Pointer plus plus. Finally return 0. I'll save the code. I'll run it. So here it is asking me the size of an array. Let's suppose it has a 6. Array elements 2, 4, 5, 6, 8, 9. Here array elements are shown. Just to differentiate them, I'm using comma. Again I will save it. Again it is asking me the size of an array. Let's suppose it has a 4. Array elements 3, 5, 7, 8. So it is showing me the array elements, that is 3, 5, 7, 8. That's all from the session. Thank you.